All right, guys, AP Environmental. This is just a short video here on, I wanted to go over the answers to this FRQ question dealing with plate tectonics. Just kind of wanted to kind of share the answers with you. And you can kind of see these in the feedback if you want to. You can click on the answers and you can see them, but I want to kind of go over them with you today. So this particular FRQ set, I actually kind of took it from two FRQ questions. I kind of blended it together a little bit, but anyway. So this first one, it shows you this map, and one of the things that again you're going to have to be able to do is when they give you a geographical map of the world or a country or whatever, you need to kind of understand what that map is showing you, even though in this particular problem or problem set, the the map doesn't really, I don't know, do much for us when it comes to answering some of the questions. But you'll see in the next set, as we scroll down in a few minutes, that it actually comes in pretty handy. So it says plate tectonic theory states that the Earth's lithosphere, or the crust, is broken into very slowly moving pieces or plates. Plate movements over vast stretches of time have led to the current orientation of our continents and oceans. So make sure that we really understand that statement. That's kind of a big picture thing. It says individual events along plate boundaries, such as earthquakes and volcanic eruptions, pose periodic threats to human activity and ecosystems. So we know that because of plate tectonics, there's this movement that could at times create earthquakes or volcanoes. It says the ring of fire is a term that describes the location of increased seismic and volcanic activity around the margins of the Pacific Ocean basin. On the map above, each dot represents a volcano or an earthquake. So again, make sure we know what the ring of fire is, around what ocean it occurs, and again, what all those points are referring to. Again, they're either volcanoes or a source of seismic activity that can create an earthquake. All right, so let's go to the question. Let's scroll down here. All right, so question one, or letter A, I guess. It says Japan, Indonesia, and the Philippines are examples of volcanic island chains that have formed along subduction zones between plates in the Western Pacific. Describe what happens when two tectonic plates collide along a subduction zone. So when I graded this, I was looking at question A and question B for the most part. The rest of it I just looked for completion. But one thing I wanted you to tell me was that in a subduction zone, one plate slides under another one. All right. If you told me that, then I pretty much counted that as correct. But another thing I want you to be aware of is anytime you have subduction, all right, you get something called a trench that forms. All right, so even though you may not have used that word, make sure you understand what it is. A trench forms at a subduction zone. The second part of that question says explain how subduction leads to volcanic activity. So if you mention that, for example, as one plate slides under another, there's heat or friction that is generated. And again, that forces magma to come up from the mantle. And again, that could create a volcano. If you talked about that in your own way, I guess, then you were fine. Most people that I've looked at were spot on with that answer. All right, question B. In addition to volcanic activity, highly destructive tsunamis are generated along Pacific Plate subduction zones. Explain how a tsunami is generated along a subduction zone. So basically, anytime we have subduction, right, it's a really slow process, but sometimes it goes faster, okay? It'll slip. And when that happens, you get an earthquake. So if you get an underwater earthquake, what that causes is think about what's above those plates. It's water. So if it slips really fast, it causes that water to push or some type of water displacement, and that's what causes the tsunami. So, yep, saying that there's an underwater earthquake, mentioning that it forces the water upwards or forces water displacement would be something to refer to as well. Describe one negative ecological impact that tsunamis have. Be sort of specific with this. All right, destruction of habitat. What types of habitats are along the coast? Because that's where that's going to happen, right? You can say things like coral reefs, maybe intertidal zones might be something to mention. Mangrove forests, those are all coastal habitats. So if you just say destruction of habitat, all right, I'll give you the point, for this particular FRQ, but on the exam, they might want you to be a little bit more specific and mention what type of habitat. Okay, so name one. You can do it. All right. You can probably also say this is something we haven't talked about yet. It's called saltwater intrusion. What that basically is when you have a tidal wave, it happens in the ocean, so it forces salt water up onto land. We'll talk more about that down the road. You probably wouldn't have known to put that down this time, but that's called saltwater intrusion. You may have also mentioned drowning of species or flooding. That might be something to write down as well, but most of you guys had something logical that you put down for that. All right, Southern California, this is question C, experiences periodic devastating earthquakes along the San Andreas Fault, which is a transform boundary located along the eastern edge of the Pacific Plate. Describe what happens to plates along a transform boundary at the moment an earthquake occurs. So, again, transform is when they're sliding back and forth, right? Plates are sliding back and forth. So, when there's an earthquake, it is a sudden change. That means the plates move fairly quickly. All right, a tremendous amount of energy is released and an earthquake can happen. So you have to talk about this like sudden movement. That's important for an earthquake. Now, the second part of this says describe what happens to the plates between earthquakes. Now, between earthquakes, again, the plates are sliding past each other, but they're moving extremely slow. In fact, it's almost to the point where they're not moving at all. And then when there's an earthquake, then there's a sudden movement. So basically, between the earthquakes, they mention they hear that the faults kind of bind or lock up, and that causes pressure. And then when the earthquake occurs, is when they actually move. All right. So make sure you can distinguish between those two things. I think that's kind of an important thing. All right. Now, question D refers to this diagram here, which shows us a series of islands. It shows us a hot spot, several different plates, shows us a mainland as well. So, for this problem here, they ask a lot about the movement of plates. So, question D, it says, based on information diagram, identify the island that is most likely to have experienced the effects of a volcanic eruption. Now, the answer to this is island E, and I'm going to tell you why. All right, again, here's our hot spot. This is an area where magma can flow up to the surface. These island chains, or these islands, are all part of plate number 2, which is moving, you'll notice, up and to the right, all right, or whatever direction that is, I guess, in the ocean. So these islands basically they're kind of moving in this direction, okay, because of the combination of the up and to the right. So they're kind of moving this way. So the inference there is that every one of these islands at one time was over this hotspot. You know, Island E is the one that's the closest to the hotspot. So it's the one that was most recently over the spot. So the answer to that question, question D again, is Island E, because again, it's the one that was most recently over the hotspot. It's the one that most recently experienced the effects of the volcanic eruption. Question E, based on the information, the diagram, and the theory of island biogeography, explain why island A has more biodiversity than island D. This question has nothing to do with plate tectonics. This has everything to do with the theory of island biodiversity that we learned back in Unit 2. So again, if you look at the islands, here's the mainland, right? We learned this a couple of units ago, that diversity of islands is mainly due to two things. Number one is the size of the island, and number two is the proximity to the mainland. So Island A, which is the largest of, well, it looks like Island D might be similar in size, but Island A, it looks like it might be the biggest one. But it's also the one closest to the mainland, so that island is going to be the most biodiverse. Island E, which is the smallest and is the furthest from the mainland, this one is probably going to have the least amount of biodiversity. Okay. Then we have our last question here. I'm sorry, no, there's two more questions. Letter F, based on the diagram, identify and describe the type of plate boundary between plates 2 and 5. So here's plate 2, here's plate 5. See how they come towards each other, right? That is a convergent plate boundary. Right? If they were going opposite from each other, they would be divergent. And then finally, G. A geologist asserts that Island E is the youngest island in the group of islands off the coast. Make a claim using evidence that supports or refutes the geologist's assertion. So again, this is similar to one of the previous questions that was asked. What you need to basically say is, again, that Island E is the youngest because it is the island that was most recently over the hotspot. And if you mention that, then you probably would be fine. All right, guys, that's it for this FRQ. That was kind of a lengthier one, but we will get more of these as the year goes on. And I want you to keep practicing answering these because it will come into play by the time we take that AP exam. All right, guys, have a good day.